Welcome back. We're looking at problem number 8 in our review packet, and we're looking at 5 different atoms or ions, and determining what kind of ion, if it is an ion, cation or anion, and the total number of electrons in the substance. So notice I didn't say valence electrons, I said the total number of electrons in the substance. First substance is lithium with an oxidation of +1. Well, +1 tells me it is a cation. Anytime the oxidation is positive, it has to be a cation. Cats are positive. Second thing, the number of electrons in the substance. We come to our handy periodic table and we look up lithium. Lithium is atomic number 3, so it has 3 electrons originally. However, it is now lithium with a +1 charge, meaning it has lost 1 electron to become like the noble gas before it. So lithium loses 1 electron. 3 minus 1 tells us there are 2 electrons remaining in lithium that has a +1 charge. And it happens to be like the noble gas helium now. Both of them have 2 electrons. That's why we say it is isoelectronic with helium. Second one, sulfide. S with a -2 charge. Well, minus tells us it's an anion, and then we look up sulfur, and we can determine the number of electrons in it originally, which is 16, according to our periodic table. And then we look at the charge, -2. Well, to get a minus charge, we have to add electrons because electrons are negative. So from that original 16, we have to add 2, and we have 18 electrons in the substance. Next up is sodium. No oxidation, therefore it is a neutral atom. No charge means we can just look at the atomic number for sodium, 11, which tells us the protons, but also happens to tell us the electrons because we know it is neutral, meaning not charged. Bromide ion. Well, anytime you see an "ide" ending, it has to be an anion. Okay? Those are the only ones that change the ending of the element using the root and the IDE rule. So it is an anion. Then we look up bromide, which comes from the element bromine, a halogen over here in the 4th period. It has 35 electrons to begin with, but when it when it gains 1 electron to become isoelectronic with krypton, it now has 36 electrons, the same as krypton. So 36. Last one, magnesium ion. Well, magnesium is a metal. There's no IDE popping up, so this has to be a cation. We look up magnesium. It is an alkaline earth metal with 12 protons and 12 electrons. Well, in order to become stable, according to the octet rule, magnesium gives up its 12th and its 11th electron to become like neon, a noble gas, which has 10 electrons. Whoop, couldn't see that up there. There you go, 10 electrons. So magnesium has 10 electrons in it. And as long as we're looking at ions, let's look at the octet rule in number 9. We want to know which ones have a full octet, meaning their valence shell has 8 electrons. Well, sodium, not the ion, because there's no oxidation, is an alkaline earth metal. It ends in 3s1. That is definitely not a full octet, so goodbye sodium. Xenon is a noble gas, so we know it's going to have a full octet. Fluorine, not fluoride, but fluorine, is number 9, a halogen. Halogens are the most reactive nonmetals, and fluorine is the king of the halogens. It is the most reactive nonmetal on the entire periodic table. Do not mess with fluorine. It has no stable octet at all, not even close. The sodium ion, Na with a +1 oxidation. Well, it's pretty safe to assume that it's going to be a full octet, but let's just double check. Sodium needs to lose 1 electron to become isoelectronic with a noble gas. So the sodium ion gets rid of its 11th electron, 10 electrons, is stable, it is like a noble gas, therefore it is a full, happy octet. Tune in for the next video for the next page.